Hello, thanks very much for having me on. I'm going to speak a little bit about natural language, both current status, how we got here, and where we're going. My starting point is so to this audience, I don't need to tell you how about AI and how popular it is. I just did want to draw your attention to a resource you may not be familiar with. It's called the AI Index. It's a project that I started at Stanford, about 5 years ago, and it puts out various things, primarily annual reports. The next one is about to come out. This is the previous report, and you might want to check it out. Lots of charts and graphs that you may find relevant. The reason I put it here beside pointing you to it is it's interesting to note that in the last report, if you look at the sort of main kind of takeaways, it's like 100+ pages long, but of the top takeaways, number one was a focus on pharma. Of course, the pharmaceutical industry is not alone. Healthcare looms very large. Again, I don't want to insult anybody's intelligence here. You're the expert in AI and healthcare. The one quote I like, I forget where it came from, is that AI won't replace radiologists, but radiologists who use AI will replace those who don't. I think it's both witty and correct. And really, a lot of the impact in healthcare was kind of in vision and image processing kind of focused. But I want to focus on NLP. And here again, I'm sure some of you in the audience know much more about this than I do, about how healthcare has been embracing natural language in various ways. I'm not an expert in the healthcare use, but I know a little bit about natural language. So this is what I want to speak about. Natural language, focusing both on the natural language understanding, how to take a piece of text and have the machine automatically extract meaning out of it, and conversely, having machines automatically or semi-automatically generate content. So let's get going. Again, I always worry that I'm insulting your intelligence, so bear with me, but I'm sure there's a lot of variance in the audience of how much you've seen recent NLP technology. So to get a sense for it, let's look at a particular model. It's something from our company called Jurassic One. I'll tell you more about it later. And it's something you can play with yourself. And here's an example of what these systems can do. So you feed it this input, and it gives you the output in the boldface. The input is, so you want to generate ideas for a blog post on electric cars. So you give an example of ideas for a blog post on AI and tourism up here. And then you ask it, well, now give me an idea for a blog post on electric cars. And you get these proposals, which if you look at it just for a second, you'll see they actually make a ton of sense. It's fairly magical. Here's another example. You want to summarize restaurant reviews. So you give it a restaurant review, an Italian restaurant review, Luigi's, and you give it an example of what it means to summarize it. And then you give it a review of another restaurant, a Mexican restaurant, La Taqueria, and it automatically generates this review, which again, as you look at it, is kind of mind-blowing. Of course, this is all enabled by what are called language models, which is slightly misleading terms. People sometimes use the term now foundation models instead. And these are huge models. For example, the Jurassic One model, which I mentioned, has 178 billion parameters. They're trained in a self-supervised way on just terabytes of data, like all the internet, and that's just the beginning. And what they learn as a result is not just how language works, but actually how the world is as described by language. And they're really good. They really give you a probability distribution over language. They're very good at detecting patterns. And if you hide part of a text, they'll predict it surprisingly well. And that turns out to be very powerful. Now, these are complicated beasts to to train. And it's not just that the mathematics is hard, that's actually fairly well commoditized by now, although there are obviously innovations all the time, but it's just hard engineering. For example, Jurassic 1 was trained on 800 GPUs over many months, costing not a little money. And so as a result, the companies who tend to sort of have these models are called Microsoft and Facebook and Google. I mentioned the two companies are really currently the only other two companies that have these mega models are OpenAI and AI21 Labs. Full disclosure, of course, I'm a member of that organization, and these the models of these two companies are really the only ones available to developers right now. I'm sure that'll change in time, but right now that is the case. Now, this is really a revolution, and it enables us to do things we couldn't do before. I'll give an example of a product called WordTune, again out of AI21 Labs. And the way to think about it is rethinking how we read and write. Because when you think about it, the way we write today is the way a product manager at Microsoft decided in 1980. And that, even if you're writing in GDocs or Gmail, certainly there have been innovations. There's autocomplete, smart compose, there's spell checking, grammar correction, there's collaboration, but the fundamental experience hasn't changed. And when we think about how we write, this hasn't changed since the 15th century with the invention of the printing press. Somebody put on a piece of paper, okay, a screen, and we just look at it. And the opportunity is to really rethink these two so fundamental skills that we have that are intertwined and that serve us in really every walk of life, and turn them into an AI-first experience where AI is not an afterthought or a feature, but kind of part of the core experience. And the machine now really becomes a collaborator, a thought partner, as much as a passive tool. Let me give you a sense of how it works with WordTune. Excuse me. So you type in the sentence, I'm reaching out about a potential partnership, and you ask WordTune for ways to rephrase it. There's several features, but this is maybe the flagship feature, and you'll get these possibilities, and you'll see that these are not trivial word replacement or synonym replacement. Rather than I'm reaching out a potential partnership, I would like to discuss a possible partnership with you. I'm interested in exploring partnership opportunities, and so on. And so the way to think about it is, here's one way to think about it. Our thoughts are highly multidimensional and nuanced, and out comes such a poor sequence of letters that is supposed to capture this highly complex thought. The chance that the particular sequence of letters we chose is the best match with our complicated thinking is low. And this is a way to explore various ways of saying things that are perhaps closer to what you had in mind. Another example that I like is you write, it was nice meeting you last night. And one of the possible suggestions would be, it was love at first sight. Sometimes it's really not what you want to say. Maybe it was a business meeting, but sometimes it's exactly what you say. And that's really the experience often is, this is what I want to say. And you can ask the system to say, well, this is sounding a little formal. I'd like to be more casual. I'd be happy to talk about a possible, I think we should discuss. Or maybe you want it more formal. Maybe you're visiting, well, I won't, I'm going to make a joke about a country, but I'm not going to do that. I'm seeking information about, I'm connecting you in concerning a possible collaboration. So you see that the system, in some sense, is helping you think about helping you think as much as say things. Anyway, that's WordTune, and there's lots to speak about. Other applications area, both by AI21 Labs and others. But this is where I want to start sounding negative. And I'm not really not negative. I mean, I'm incredibly bullish on this. I mean, we have a horse in this race, and incredibly optimistic. but we should also have a sane view of where things are. And here's an example. So Squad used to be the test bed for natural language understanding. This is a standard question answering data set. Initially, it was way out of reach of machines, and then suddenly, with the advent of in particular transformer-based architectures of neural nets, met and arguably exceeded human-level performance. It's very impressive, and I won't get into how this constructed, but you need to understand a little bit to understand how there's sort of cheating going on here. So here's how it works, and this is from a paper that followed very closely, and this is prehistoric in the pace of AI these days. But even then, people point out to a flaw here. So the way the question answering data set works, you give it a paragraph, and you give it a question, and the John is to find where in the text lies the answer. And here is the system gave you correct answer. It was John Elway within the text. But here's the thing: you add a distractor sentence. Quarterback Jeff Dean has jersey number 8, which has nothing to do with a period paragraph, and certainly nothing to do with the question. And now the system just latched onto Jeff Dean as the answer, which is funny because it has nothing to do with Jeff Dean, this amazing guy from Google who runs Google Brain, different Jeff Dean. And this is not episodic. If you look at the average scores, they drop precipitously from something very high, like 75%, to half that, and even less if you're a little adversarial with the system. So that was an early cautioning sign that these very impressive performance should be taken with a certain grain of salt. Now, if we had more time, I'd give you more examples, but trust me that this pattern of amazing performance and then pointing out to, oh, there's overfitting here, it's quite fragile, is common. That typifies the field. We have a similar experience in natural language generation, where you ask the system to generate text. And here we don't quite have benchmarks but you have impressionistic sort of experiences, and clearly GPT-2 and then GPT-3 is a system that opened up the imagination of people here. And it's incredibly, if you hadn't had a chance to experience it, please do, and you'll be blown away. And so this is GPT-2, the earlier and smaller model. You give it an initial sentence such as, artificial intelligence is the art and science of enabling machines to exhibit the sort of intelligence that some people exhibit. And you ask it to continue and, just generate a cogent passage based on this. And it will do that. I don't expect you to read all of this, and I won't read all of it, but it starts with the advent of robotics and or AI. It's possible to create objects that are so intelligent and so on. And it ends up with what might these machines really be like? And what does it mean for the way we think about humanity? And trust me, this whole paragraph reads very cogently, and it's mind-blowing. But it's really the exception rather than the rule. This is more typical of what you get with these systems. You put an initial sentence such as, text generation technologies today show great signs of progress as evidenced by GPT-2, Grover, Haim, and you ask it to continue, and it'll start almost sensibly, say both of these technologies, you mentioned 3 right off the bat. That's a little rough, but never mind. They generate code. Well, why code that doesn't alter existing application in a meaningful way? You can kind of say, well, it kind of makes sense. But then he speaks about GPT standing for good parts in front of parts, and speaking of anyway, it just goes off the rails and makes absolutely no sense. And there are various quotes that make fun of GPT-2 and GPT-3, and I want to be clear, this is not singling out, the OpenAI model. It's true of our models just as well. GPT-2 shows flashes of brilliance mixed with gibberish, and so on. And these really are machines that are amazing statistical machines, but don't understand what they're doing. to get more of a feel for it, here's some actual input and output from GPT-3. And again, I want to emphasize it's not a bash on GPT-3. It would be true for other models as well. So which US cities have more than 20 million citizens? And like a good MBA, it'll give you a confident answer. New York, Los Angeles, Chicago, and so on. The point, of course, is that no US city has more than 20 million citizens. But the language model doesn't know that. It just looked at the statistics, found the statistics were best match, and outputted it. How many teeth does that person have? 32. Well, that's cool that the language model learned this. How many teeth does the math teacher have? 47. Why? Well, that's what the statistics told it. It really has no idea that the math teacher is a person. What date is it today? It'll give you some date that it decided was the date, having nothing to do with the date on which you asked it. You asked to do addition. What is 10 plus 11? It'll give you the right answer, 21, which, by the way, is, I find, mind-blowing. Nobody trained these language models with the idea of they having to do arithmetic, but they do. If it's two-digit arithmetic, what is 1982 plus 39? You get garbage. They have no idea what arithmetic is. So these are really statistical machines. They're not intelligent. And where did that take us? And here's where you need to make a bet. There are those, I don't know that anybody really believes this, not even OpenAI, that maybe are the poster child for the brawn side of things. Just add more data, more training time, train larger models, spend not $10 million, but $10 trillion, and eventually you'll get intelligence. The system will know how to reason about math and time and causality and all of that. And there are others who don't believe that the system will learn how to do addition even at the competence of a 1970 HP calculator. They'll make less mistakes, but they'll really never understand arithmetic. And that's a bet everybody needs to make. And here's a bet that I believe in, that we really are at the third phase. If you look back at the 80s, and the data in the AI index will back it up, AI was very popular in the 80s, not quite as it is today, but pretty damn close. And then, of course, you couldn't admit you were doing AI in the 90s, even if you were. But AI looked very different back in the 80s. It was all about symbolic systems with very little data and a lot of reasoning about time and causation and all that good stuff. And then we pivoted, and all we do is statistics. Lots of data, no reasoning. And I believe that if we want to go past pure pattern discovery, pattern recognition, and really understanding, we need to merge the two. We need to take the symbolic reasoning, whether it's math or reasoning about time, or accessing all kinds of information, resources, and reasoning technologies, and merge them with the amazing capabilities of modern statistical language models. What this first phase will look like, you'd be able to do reasoning about, math and time and causation and what have you. You'd be able to access, you want to ask a query and basically impart the answer on patient records you have. This is not something data that the language model had, but you want to access it. You want to know something about current, data like COVID numbers. You'd be able to go access an external website or some information resource and include it in your answer. And do all of that while maintaining the amazing capability of the language model. How to do that? Well, that's, I think, different people have different ideas. Sometimes under the header of neurosymbolic models. And we ourselves are going to make an important announcement about this, actually, I think a couple of days after this conference. So please look out for that. And I think we're headed for really exciting times. And hope this was useful. And thank you very much for your time.